Okay, cool. All right, so cool. Can everyone see my screen again? Awesome. Great. So yeah, today we're going to be talking about testing API calls. It's something I've thought about ever since I started working, and my thoughts have evolved and my practices have evolved. So I'm hoping at the end of this talk, we will have, like a discussion about, you know, how we can improve what the talk explained. So yeah, a little bit about me. I'm Adi. My pronouns are he, him. I've been working as a software engineer for 5+ years, mostly with Elixir. I'm currently writing a book with Pack Publishing. It's an Elixir book, but more to come on that in future meetups. I love theoretical physics, Elixir, test-driven development, systems design, and catching software bugs. Um, so if anyone has anything they want to talk about this, hit me up. Yeah. So today we'll talk about testing API clients. Can't really talk about it properly without an example application. So I built a small example application. I'll cover its components so we understand that well enough before we cover different strategies to test it. And then we'll get into different levels of testing API calls. I think there is a hierarchy. There's a hierarchy there. That's why I'm calling it levels. But people might disagree. And we'll finish up with like an Ask Me Anything session, Q&A, but we can just chat about anything. And yeah, great. So the app we're going to be talking about today is PokeHub. Whenever I do presentation or talks on API clients or APIs, I always use Pokemon API. It's like my go-to. This and if you didn't if you couldn't tell, the start of this meetup I was playing Pokemon music, and this talk is going to have like a lot of Pokemon gifs and stuff. So if you hate Pokemon for whatever reason, you might not like this talk. Also, why would you hate Pokemon? Something's wrong with you. So anyway, so yeah, PokeHub. It's a simple mix project. It makes calls to Poke API, and right here you can see PokeHub makes a GET request to Pokemon API, with the route Pokemon and the Pokemon species name, and it gets a response with the ID of the Pokemon's weight, height, and whatever, right? And once it gets a response, it parses that and puts in a struct internally represented inside the app as Pokemon struct. So very simple app, no Phoenix, nothing, just a simple mix project. Great. Now it has a module, the main module called PokeHub module. It defines a function get Pokemon. And again, it gets the Pokemon based on the species name. And which also uses another function called parse Pokemon to parse the HTTP response into the struct that I mentioned. Again, I've eliminated a lot of logic here, just showing you the interface. Here's a type spec for that. Get Pokemon takes a string, a species name like Pikachu, and returns OK Pokemon or error, like a whitelisted set of errors. And like I said, it's a main interface to the application. And rest of the implementation is like in a different module, like what URL to make call to, what parameters to set and all that, right? That's separate. And making a call to get Pokemon returns a valid Pokemon species. Like here's an example. If you do PokeHub.get Pokemon Pikachu, it returns OK and, Pikachu's whatever details. And the second module is Poke API, and that is used by PokeHub. It has a get function, which returns a response body, and the HTTP response that you get, its body, and and errors like not found or some error that happened, other API error. I just showed like a very little implementation over here, but it takes like species and returns OK body, error, and type of error. And this body further gets parsed in the PokeHub module that I showed here. Cool. And Poke API has the request function as well, which just makes a call, gets like species URL, has information of the API, like what URL to call to and what path to go to, and then further calls to a module HTTP to make that request. Great. Now HTTP module, which is used by Poke API, it's a simple wrapper around HTTP Poison, which is like a well-known Elixir HTTP client. I wanted to use a client named Finch. It's a lot faster and better, but I'll explain further why I couldn't use it. And it implements a function request, which takes an argument URL, and all it does is makes a get request. No parameters, nothing, very simple, right? And returns an HTTP response or an error. Great. So just a summary. PokeHub is the main module, which makes call to get function in PokeHub, Poke API, which further makes call to the request in HTTP. So HTTP is used by Poke API, which is used by PokeHub. Great. Now let's get to testing it, right? So the first level of testing is actually it's pretty good and totally fine. It's having a real-time API test, actually making the call and testing it, right? So get Pokemon in PokeHub with Pikachu, you expect it to return these attributes and assert that it returns that. And if it's like a bad species name, it should say not found. And pretty straightforward. Now you guys might guess what the pros and cons are here, right? Pros are it's very easy to set up, right? Just making an API call. It also tests the actual behavior of the API, right? So you're always testing whether the API is working or not, right? You're not really using any mocks or any other layers. So it's closer to testing the actual behavior. And you will know when the API has changed because you're making the call directly. However, on the flip side, it relies on the API's availability. That means if I want to test this locally, I need the API to be accessible. It's not good for like paid or limited HTTP services. Some services you have to have an API token you cannot share with every person who is developing. And if you have a limited number of HTTP calls you can make, then you're using that up for testing every use case. And tests will be slower because it's an actual HTTP call. Not every test needs to make an HTTP call and be slow. Great. Is everyone following? Awesome. Cool. Great. So level 2, mocks. So mocks is so there's this really cool article by Jose, the creator of Elixir, and this was in 2017, I think, and I will put that in like the notes of the meetup about how he envisioned using mocks in Elixir. And he said the key was having explicit contracts. And mocks is a library which uses behavior, Elixir's behavior construct to define a contract. Behavior in Elixir is like kind of like an interface, like to like what like for a module to implement a behavior, it needs to define a specific set of callbacks, right? Or implement a specific set of callbacks. So we can wrap the HTTP module into a behavior and call it HTTP behavior and say, okay, it needs to define a function request, which takes a string, which is a URL, and return an OK and a response or an error and an HTTP error, right? So that defines the behavior, and we can update the HTTP module then to use that behavior and implement it. So no real changes here, but we just just wrap that definition into a behavior. Now, doing that allows us to really use the power of mocks, because mocks allows us to uh, define uh, uh, behaviors more easily that we can use for specific use cases in our tests. Let's see how. So first, we need to change Poke API to not use the HTTP module directly, right? Because based on how we configure things, we wanted to use an implementation of the behavior. And we can, wrap that into environment, application environment. We can say, okay, whatever PokeHub is configured to use as HTTP implementation, let's use that to make a request and default it to the old HTTP, right? And this is something, HTTP is something we'll use in production and dev, but in test, we can use, a different implementation. So now we can use mocks to define a mock in our test environment in the test helper. And it can be done by doing mocks.defmock. And it says, okay, we're defining the mock for this behavior. Great. And this explicitly defines a mock implementation only in the test environment. And again, this happens before the tests start running. It's very important. You're not dynamically defining modules. Great. Now, once you have all the setup ready, you can update your application environment to use HTTP mock, which we defined in test helper. And, oops, sorry. And in your setup block, you can say, okay, expect HTTP mock to get request. And when you get a request with this URL, let's return OK with a body. And if it's any other URL, let's just return 404. Right? So this is like mocking the Poke API, and we're setting the mock's behavior right before the test. So we can test both the cases. So if we use name as a species, we get OK and Pokemon, right? Oh, I'm not able to get rid of this. Maybe I'll do full screen. There you go. Yeah. And if we use any other name as species, we'll just get error not found. Does this make sense? Let me actually see everyone's videos. Does it make sense? Awesome, cool, great. So pros and cons. It doesn't rely on API's availability, like testing real-time requests. Explicit contracts and form of behavior. So your behavior defines how your mock should function. So if you are following the behavior correctly in the test environment, your mock modules will follow the API's behavior. There's also a really cool library called Hammocks, which is built on top of mocks, which ensure that your mock calls match the type specs, which is also very important. So you can use that and kind of have a stronger contract. Now, cons are it needs a lot of maintenance because you have one mock per use case, right? If your API changes, you have to change all the mocks, right? So it's definitely more work. It is not consistent with API changes because if your API changes, your mock is still in your application. You're not going to know that your API has changed. So your test will pass even though production will break, right? And behaviors are, I don't think behaviors are great for contracts because you don't even get a compilation error in Elixir. So I think we need a stronger way to enforce contracts than just mocks. I still think it's a step above from just doing real-time tests. Great. Now level 3, and this is my go-to way of testing. If I have to do, do API testing, I'm like, ExVCR, I choose you. I pick ExVCR. Okay, enough. I'm not gonna do Pokemon jokes. Sorry, but yeah. So ExVCR, as the name suggests, it's like VCR for HTTP interaction. Like, what does VCR stand for? Video recording something, whatever. Does anyone know? I think it's video and recording. I don't know what C is. Cassette. I guess it's cassette probably. Video cassette recorder, probably. Anyway, so yeah, instead of video, you're recording HTTP requests and responses. And they are recorded in form of JSON files, which are called cassettes. And really cool thing about it is it's like the framework is really built on top of that the JSON file to support different use cases. For example, it allows you to filter sensitive data like passwords and auth tokens and IDs. So you don't want to like add that to your source control. So it supports all of these things. And a big thing for me is that they can be manually updated. So once you have a structure for your API, you can manually generate those JSON files for different use cases. So yeah, it's very flexible in that sense. And it works with like libraries like HTTP Poison and HTTPC. And this is one problem with ExVCR that doesn't work with Finch yet, which is I think probably the best, well, my favorite at least HTTP client to use in terms of interface. So hopefully it will support it soon. So if we replace all of that with ExVCR, our setup becomes very minimal. All we have to do is set up a cassette library directory where it's going to put all the JSON files. And all you can do is like say use cassette for every use case. So if for a valid use case, you can say use cassette valid Pokemon. And when you do Pokemon.get Pokemon Pikachu for the first time, it will actually record the response and put it in a JSON file. And by default, every other time, it will just reuse that JSON file. So you can record like responses for a valid and invalid Pokemon, and they'll be very close to, well, not very close to, they'll be identical to what your API responded at that point in time. So you won't be relying on your ability to write mocks like you would in the mocks use case. Great. So pros and cons. Doesn't rely on API's availability, just like mocks, but the contracts are in form of JSON cassettes, which I think is much better than behaviors. It doesn't give you compile time errors, but it can be used by front end as well. Like you cannot share your Elixir behavior with the front end that's written in JavaScript, right? But this JSON cassette, you can share that as an example with front end, and you can use that to establish contract. Great. An easier way to maintain compared to mocks. Like I said, like you can see, the setup is a lot less. It's not code, it's JSON, which is programmatically generated. So I find it's a lot easier to maintain. Cons, again, it's not consistent with the API changes because if the API changes, again, the same problem, right? Your JSON is already generated. You're not going to know that. Your test will still pass. And doesn't work with Finch, like I mentioned. That's a big con for me, actually, because I use Finch in all my projects now. So I haven't been using ExVCR. So actually, I was wrong. So I don't choose ExVCR every time now. So yeah. I'm going to pause for questions or thoughts before we get to this mock server.
Question.
Yeah.
Couldn't you set up like a timing-based script that just automatically does the manual update to remove that first con?
Totally. Yeah,
At least,
totally.
I guess you wouldn't remove that first con. You theoretically have like whatever the time window is between you running your test locally and whenever that next update is. But you could drastically reduce your exposure to that surface.
Right. So you're talking about the inconsistent API, right? That con?
Yeah.
Right. Yeah, totally. I actually did do this, and this is something I'm going to talk about in further down. Yeah. So one of the great ways you can do it, simple ways, is like every night you can run a nightly script that makes actual API calls for only a couple of the JSON test cases, and if there's any git diff, it breaks. Right. So like stuff like that. Like there's totally you can write stuff on top of this and add consistency to it. Yep, totally. Yeah, unfortunately, it doesn't support it. There's no clean way of like, configuring ExVCR to do that, which would be nice if you can in ExVCR itself you could, add a way to do that. Like if your JSON files are old, for example, since they were last saved, something like that, right? But yeah, because it does store request time in the JSON file. So based on that, maybe, yeah, I don't know. We should definitely maybe yeah, we should suggest it to them. I actually am just thinking about this just now. Sorry, good question. Any other thoughts? All right, so let's get to mock API server. Uh, so actually, yeah, one of the problems with ExVCR and all of these things is that it's you're testing what you get from a server, but it's not really an HTTP request, right? So I think another step up from this is like creating a mock API server, um, and it's actually closer to mimic an API call because it's an actual HTTP request. And you know, if for example your server is like taking a while to process a response, it can like even sleep. You can add sleeps to your mock API server and whatnot, right? Like it allows you to test your HTTP calls better. Um, right. So here's an example of that. We can define so in Poke API there was a base URL defined, which was this, right? Because there's only one Poke API. We can make it configurable, right? Just like we made the HTTP implementation configurable. Um, and you probably guessed we can change that configuration for testing. So now let's define a mock server. We can use Cowboy or GenTCP, whatever you want to use. Quick plug, in the book I'm writing, it teaches you how to build a web server from scratch. So if you're interested to know how to use GenTCP to write a web server. Anyway, so the mock server here, you can see I define a route for just species. And this like format is like consistent with like Cowboy. So yeah, it's a species, it's a like a required um, non-empty parameter. And basically, if the species is Pikachu, we respond with 200 with the data. If species is anything else, we just do 404 with not found. Again, I've hidden all the other implementation. Um, cool. So now we can mock our server. In the setup, we can update our application environment space URL to not be Poke API and be whatever is the port and IP of our mock server, which I assume we're running locally. Like I don't have the code for that, but in this app, I had configured it to run to start in test environment. So it would be running anyway at port 4040. Great. And you can just make a request because now all your requests go to that API server. And when it's Pikachu, you get a 200. So OK and Pokemon. And if it's anything else, you get a 404. Not found. So yeah, this is another way you can test your mock API or yeah APIs. So pros and cons again. Oh man, what is this? Right, right. So I didn't recognize this for a second because I just added the slides today. So okay, so it doesn't rely on API's availability, same as the previous two levels. And HTTP calls more closely mimic the actual API request. So yeah, that's one thing the other levels are missing. And this, yeah, I mean, can be used for tests that take longer to process things, right? Especially say if you're testing scalability of your application, or rather stress testing your application, right? And one of the parts of the application is an API call. It's better to use this than, you know, ExVCR because ExVCR doesn't properly communicate, you know, whether your application can handle that stress or not. So yeah, cons are it's again inconsistent with API changes. It's hard to maintain, right, than other options because you have to write a web server and it has no contracts. So yeah, these are basically the four levels of API testing. There's a level up above this. It's not quite level 5. It's it's 9001. Basically, it's quite a few levels above this. It's using a combination of all. and using ExVCR to test direct HTTP calls, right? And you can use mocks not at HTTP level, but at Poke API level. So, in that way, your other tests will be much smaller and maintainable because you're just mocking only the module that uses HTTP. So you're mocking a lot less. You can use mock API server to do load/stress testing. And you can use real-time API to determine whether API has changed. So yeah, a combination of this, I think would be a good, I think covers all the use cases. Um, yeah, that's pretty much it. Any questions? Thoughts?
So I know that this is an example application, so this may be self-answering, but why would you, so when I call the API, it's returning an object, right? It's not immediately turning that into the Pokemon object, like that's a second parser that you have.
Right.
Why would you not separate that out into a unit test and then explicitly test the API on the response it gives rather than the Pokemon object?
Right. Totally. I just chose to test PokeHub module in this case. I wanted the test to be like simple. Instead of having to write an entire response to test, it's easier to test like a struct. But yeah, I would.
The case. Thank you.
Right. Yeah, I would otherwise only test the HTTP calls. Yep, that's a very good point.
I assumed your levels were arbitrarily chosen by you, but then you struck me with the 9001. Is there something I'm completely unaware of in testing levels?
I wanted to use this GIF. That's it.
I'm sorry, was that a Pokemon reference?
It's unfortunately not Pokemon. It's Dragon Ball Z, but yeah, anime. But I was thinking, initially I put it as level 10. I'm like, it's like definitely a few levels above. I wanted to communicate that because it's like a combination of all. But I'm like, wait, level. It's a very popular meme. So it automatically came to my head.
All right, nice. And then, so mocking is something I've only, matter of fact, I don't think I've ever done it with Elixir. I think only in my Python days and stuff like that. With level 4, are you testing delays, drop connections? Is there any way to simulate that kind of stuff? Or are you really kind of just waiting for later to do that?
Yeah, I mean, you can introduce like a randomness to your server, right? Like it randomly drops. It really, I mean, that's where the possibilities start like opening. Okay, I'm going to stop recording, I guess, actually.